Hi, this is the Desmos solution video for the transformation non-rigid motion golf. And I'm going to just play some different solutions. This is challenge number 1, slide 2, simple translation. That one looks great. Challenge number 2, a little bit more variety here. One solution was dilate and translate. I don't remember if I saw any others. I'll take a quick look. Yeah, there were quite a few people that did translate, then dilate. And then this next one. On this next one, there's not really an animation, but Dia is correct. And the way I did it was I just kind of played around with it. It seemed like most everybody was comfortable with that one. And this is challenge 3, which would have been slides 5 and 6. And here's a pretty common solution: dilate, then translate. And as you probably guessed, some people did translate, then dilate. It's interesting. I usually do the dilate first, and you can see that if you look at the class results, you'll see people have a tendency to go one way versus the other. Challenge 4 was a little bit harder. This person did 4 steps. So they did a reflection, a rotation, a translation, and a dilation. Here was also a really nice solution. They used less steps. So that was a great solution. But probably the most smooth one was this one, 2 steps. So good job on that one. This was the dispute problem that people were missing that I talked about in 3rd period. And so 1st period kids, a lot of people just thought that you couldn't do this with a dilation, and that the reason for that is because you hadn't really learned about negative dilations. But a negative dilation of 1 would just maintain the size. But if you imagine this being a coordinate plane, I'm going to pause to draw. So if this was a coordinate plane, and this point here is 1, 4, for example, a -1, a 1 dilation would just keep the figure exactly the same. A 2 dilation would make it grow out this way if the origin was the center of the dilation. But if you had a -1 dilation, it would take each point, like the coordinate 1, 4, and make it opposite. So you'd have this coordinate down here, -1, -4. And so they're both correct because you can do it with a dilation of -1, which is essentially a 180-degree rotation. So challenge 5 gets a little bit harder, but reflect was common. Although there were other solutions, really the reflect was the most common, and the other ones were a little clumsier. So we'll go to the next challenge. So this challenge, one of the common solutions was reflect out of the box and then rotate. And then I really like this one. Some people are starting to use reflections over oblique lines, so not horizontal and vertical, and they're finding some really nice solutions. So that was a good one, reflect, translate. And you can see on the next slide, it was a question about the different possibilities. So most people selected a reflection by a rotation or a reflection by a translation. But there was a few people that came up with 2 reflections, and I think the problem with 2 reflections is if you reflect to the right, for example, then you would reflect again and you wouldn't have the correct orientation. And I hadn't really thought about the 4 reflections. But you maybe can play a little bit around with that. And I'm going to go to the next slide. So this next solution is really great visual spatial thinking. I was super impressed with that one. And I think this one was more, maybe a little more popular. And it's the way I thought of it. I really didn't think of it the other way, and I loved learning from that other solution. And this one is maybe the more common one with reflections, just a reflect right and a reflect left. So those are 3 really good solutions to challenge 7. Here's a solution to challenge 8. Again, making use of that oblique line. That was a great one. Reflect, dilate, and reflect. Really thought that was great. And this one just so, oh, I didn't realize this one had so many steps. Let's see what happens. Dilate, rotate, translate, reflect, dilate, translate, reflect. Wow, that took a lot of persistence. That was great. And here's one more solution. So dilate, reflect, rotate. It's so little, it's kind of hard to see. Oh, I don't think that one worked. Oops, so that one didn't work. So just the other 2 were the more common ones. There were quite a few long ones. And then slide 16 and 17, the correct solution was, and we talked about this one in 3rd period a little bit, in a sequence of translations or reflections or rotations, that would always make something congruent. So everything about the shape size is the same. But once you put dilations in, the only thing that is guaranteed to be the same is the measure of the angles. And then on this last one here, any translation can be replaced by 2 dilations. Because you can, like, we saw somebody do that earlier where they had that barrier, they had to like shrink up that L and then slide it over, and they grew the L. But a translation can't be replaced by a rotation because it would change the orientation. And a dilation could change the side, but reflections don't. And in a reflection, can't always be replaced by a rotation, but it could be sometimes replaced, by a combination of items. But one rotation, like for example, it could be replaced by 2 rotations, but maybe not 1. And so we're going to go to this last challenge here, challenge 18. And so here's one solution that worked. This was a tough one. Going back to that reflection over the oblique line, that's a good one. And only 3 steps, which is really great. This one is a little, oops, that's not that one. This one is similar, but in a different order. So the rotation happened first, and then the translation, and then the dilation. Those were 2 common solutions. So hopefully that gives you guys some help with the slides.